We have a Dagger dependency graph with 3 scopes. Let's walk through the generated code for each of the layers to get familiar with how everything is hooked up. Let's start with the main activity. The main activity injects an activity-driven screen navigator. This class has an inject annotated constructor as well as the activity scope annotation. So where does it come from? We know the main activity component is the glue between the main activity class and any dependencies it injects. So let's go to that, and let's look at the generated version of this. Dagger main activity component has an inject main activity method that is called when the inject function that we defined on the component interface is called. This calls a generated members injector class that assigns a screen navigator to the field on our main activity instance. It gets a reference to this screen navigator from the generated provider. Since our activity-driven screen navigator is scoped, that provider is wrapped in the double check provider that ensures only one instance of this is created for the lifetime of the component. So any subsequent injections will return the same instance. There's also another method here called screen navigator. This comes from the navigation depths interface that our main activity component extends. When Dagger's running code generation, it sees that it has this interface method that it needs to fulfill. So how does it know where to get a screen navigator? We actually told it how in the main activity module. If you delete this module and try to build the app, Dagger has a great error message for that, saying there's no binding for screen navigator. Yes, it knows about activity screen navigator, but it does not know that it should provide that when somebody requests a screen navigator because we didn't explicitly tell it. This binds function in the module told Dagger, if a screen navigator needs to be provided, just go ahead and use this implementation. It uses the same activity-driven screen navigator provider that is used in our main activity to fulfill the screen navigator interface method. Notice how this module method is actually unused. It's just a reference for Dagger during code gen. So now our main activity is injected, and the first thing it does is add a home fragment instance if our app is being cold started. Let's go to the home fragment next. Here we inject an app view model factory. Looking at this class, it's constructor injected with no scope annotation. So where does this come from? Just like before, we know the component responsible for gluing the fragment and its injected dependencies together, and in this case that's the home component. Looking at the home component interface, it's a little different than our main activity component because we have a couple declared dependencies. Let's look at the generated component and see how everything is different. First, we'll find where AppViewModelFactory is coming from. Since that class injects a map, Dagger builds the map out of the multi-bindings that we declared in the home module. Once again, this module is only used as a reference during code gen. So we call inject on our fragment, and this inject home fragment method gets called. It looks just like the one we saw for the main activity. The value is assigned to the instance field on the fragment, and we're all set. The AppViewModelFactory gives the home fragment an injectable view model. The view model itself requires an app repository and a screen navigator, which it gets from the component dependencies we passed in. The generated view model factory requires providers for its dependencies, so Dagger just generated some small provider classes that wrap our dependency interfaces. This screen navigator provider is wrapping the screen navigator that's returned from the main activity component's provider via the navigation depths interface. But in tests, it actually comes from the test application component. Home component doesn't care where it comes from, only that something is behind the navigation depths interface and providing it. Now, what about app repository? That's coming from application depths, which our application component extends. Let's head there next. Our generated application component is pretty slim. It sets up dependencies needed to create the GitHub API instance, which itself requires a retrofit instance, which itself requires OKHTTP and Moshi. All of this setup is so it can create an app repository and fulfill the interface method to provide it. We've traced a path from the first injection in our app, which is the activity-driven screen navigator in the main activity, to the home screen. Most of the Dagger magic is in the code generation process. The generated code itself, while sometimes containing more hoops than we'd assume, is really not far off from what we'd write ourselves. With that said, please don't feel discouraged if there are things that still aren't quite making sense. Dagger 2 is a tool that has a very steep learning curve, but once it sinks in, it will stick. It just takes time working with it and trying out new things to make Dagger work best for you. Keep looking through that generated code.